You ever wonder why we don't have those helpful robots we see in movies? Folding our laundry or tidying up the kitchen? Well, it turns out a massive piece of that puzzle is just how crazy expensive it is to teach them. But a brand new breakthrough called VLA-Adapter might just be the tiny key that unlocks this huge potential.
It's a fair question, right? We've been promised this stuff for decades. But in the real world, getting a robot to just understand our world and our commands is a monumental task. And the biggest, most expensive hurdle has always been the robot's brain.
And this isn't some small problem. Just think about it for a second. Teaching a robot to see an object, understand a command like, hey, pick up the red block, and then translate all of that into precise physical movements, that requires an AI model of staggering complexity. And until now, training these models has taken months of work on supercomputers, costing an absolute fortune.
To give you an idea of the change we're talking about, just look at these numbers. The old way, the previous state-of-the-art model, had 7 billion parameters. You can think of those as the neurons in the AI's brain. And it took 304 hours on specialized computer hardware just to train it. Now, the new way with VLA-Adapter, it's got just 500 million parameters, and it takes only 8 hours to train. That's not just an improvement. That is a seismic shift.
Okay, so let's really dig into this. To appreciate just how big a deal this is, we first need to understand the exact problem researchers were stuck on. You could call it the robot brain bottleneck. The technical name for these robot brains is Vision Language Action Models, or VLAs for short. It's actually a pretty great name because it tells you exactly what it does. It takes in what the robot sees, what it's told to do in plain language, and then figures out the action it needs to take. The real challenge has always been making that connection, that translation, efficient.
And that inefficiency created these 4 huge bottlenecks that held everything back. First, the model sizes were just enormous, which makes them really hard to work with. Second, as we just saw, the training cost was insane. Third, they gobbled up a ton of expensive GPU memory, or VRAM. And finally, their inference speed, which is basically how fast they can think, was often way too slow for a robot to act smoothly in the real world. So how do you get past these roadblocks? Well, researchers realized the core problem wasn't really the robot's eyes or even its arms. The real issue was the communication highway connecting them, that link between what the robot perceives and what it actually does. Let's stick with a human analogy here. The robot has a perceptual brain, which is a vision language model, or VLM. This is the part that sees and understands the world. Then it has a motor cortex, which is called a policy. This part controls the robot's body. So the big question is, how does the perceptual brain send the perfect, most efficient message to the motor cortex so it can get the job done right?
Well, it turns out the perceptual brain can send 2 different kinds of messages. On the one hand, you have raw features. Think of this like the full, unabridged, super detailed report with every single little detail. It's got all the info, but it can be a bit overwhelming. On the other hand, you have an action query. This is more like a short, concise executive summary that's totally focused on the action. It's designed to get straight to the point. And here's the kicker. The best solution wasn't to just pick one or the other. The real magic, the thing that earlier methods just couldn't crack, was figuring out the perfect blend. How much of that super detailed report do you actually need, and how much of the quick summary is enough to get the job done? And this is exactly where VLA-Adapter comes into the picture. It introduces a totally new and frankly incredibly clever way to build that bridge between perception and action. The secret sauce here is a new module called Bridge Attention. You can think of it like a smart, super efficient manager that sits right between the robot's perceptual brain and its motor cortex. And its only job is to look at both the long, detailed report and the short, punchy summary and, for whatever task is at hand, dynamically blend them together to create the absolute perfect command. So the whole process is really simple but incredibly powerful. First, Bridge Attention gets both types of information at the same time. Then it learns how to decide exactly which parts of each are most important, basically finding the perfect recipe on the fly. And finally, it sends out a single, precise, high-quality command that the robot can execute without a hitch. Okay, so does all this clever design actually work in the real world? Oh, yeah. The payoff here is where things get really, really exciting. The results are nothing short of stunning. First off, let's talk about size. The VLA-Adapter isn't just a bit smaller, it is tiny.
It is 1/14th the size of the previous leading model. That is a massive, massive reduction in complexity. Next up, the training cost. This is just wild. It's 38 times cheaper to train. Just think about that for a second. What used to take weeks of supercomputer time can now be done overnight on a single machine. That's a game changer. And finally, speed. It's 3 times faster at making decisions. Now, that might not sound like a lot, but in robotics, that's the difference between a robot that feels slow and clumsy and one that feels incredibly fluid and responsive. But here's the most incredible part. The real kicker. Despite being tiny, cheap to train, and super fast, it doesn't sacrifice performance one bit. In fact, it actually performs slightly better than the giant 7 billion parameter model. It is the definition of punching above its weight. And if all that wasn't enough, the researchers found a huge surprise. VLA-Adapter works beautifully even when the main perceptual brain, the VLM, is frozen, which just means it isn't being trained or changed at all. Under those exact same conditions, the old method completely collapses. It has a 0% success rate. This just shows how incredibly robust and efficient this new bridge really is. So, what does this all mean? Why is this more than just a really cool academic paper? Well, let's connect the dots to what this means for the future of robotics. Look, the takeaways here are absolutely huge. This breakthrough pretty much democratizes AI research in robotics. It just crashes the cost and time you need to do experiments. Suddenly, smaller labs, universities, even individuals can train a state-of-the-art model on a single consumer graphics card in just 8 hours. It's all about getting top-tier performance from a tiny model, and that paves the way for making robots that are actually affordable and accessible for everyone. The researchers who wrote the paper summed it up perfectly. They said, VLA-Adapter alleviates VLA's reliance on large-scale VLMs and huge training costs, lowering the barrier to deploying VLA. It's really that simple. They're lowering the barrier to entry for everyone. And that brings us right back to where we started. With these massive cost and complexity barriers just completely shattered, the question is no longer if we're going to have helpful robots in our daily lives. The new question is, what are all the amazing new things we're going to teach them to do first?